Hello and welcome to today's Buildings Group webinar, Securing Your Building's Most Critical Assets, sponsored by our friends at Dragos. My name is Robert Nieminen. I'm the Chief Content Director of the Buildings Group, and I'll be acting as moderator for today's presentation. On behalf of my fellow presenters, we appreciate you taking the time to join us today. We'd like to extend a big thank you to today's sponsor, Dragos. The company was founded by renowned ICS and OT practitioners who have defeated adversaries for the US government, ally nations, and global firms. Today, Dragos is on a mission to protect the world's most critical infrastructure and to safeguard civilization. This webinar has officially started, so if you cannot hear me speaking, first, please check to make sure your computer mute button is turned to off. Second, please log off and log back in. If you still cannot hear me or have any other difficulties, please contact tech support by typing your message in the questions window on your screen, and our technical experts will assist you. Also, please note, we recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We'll answer as many questions as possible during the Q&A session that will follow the main presentation, but feel free to send in your questions at any time. To do so, simply type your questions into the question window on your screen and hit the submit button. If we don't have time to answer all the questions submitted in the event today, we will be sending them to our sponsor, Dragos, for follow-up. For a copy of today's slides and other valuable resources, you can refer to the Event Resources section on your screen. Today's resources from Dragos include an infographic, Identity and Protect the Crown Jewels of Building Automation Systems, a white paper, OT Cybersecurity Risks of Leased Data Centers, a solution brief on cybersecurity for building automation systems, a case study on securing the critical environment that runs data centers, and Dragos demo request link. Also, please be aware that today's session is being recorded and will be available on the Smart Building Technology website within the next week. You'll be notified by email when the archive is available. And now it's my pleasure to introduce today's speakers. Daniel Gaeta is Senior Solutions Architect at Dragos, and Zachary Spencer is the Senior Enterprise Account Executive at Dragos. And with that, I'd like to turn things over to our speakers, Daniel and Zachary.
Hello, everyone. My name is Zach Spencer. I'm an account manager with Dragos, dedicated specifically to the building automation systems market. I've been with Dragos for about a year, and in the building automation space for 8 years and counting. It's mostly spent with first-party building automation manufacturers like Carrier, Honeywell, and Siemens. My experience this far has been centered around sales and deployment of secure building automation systems networks for both large multinational corporate customers and smaller local financial institutions, education, and healthcare systems. I'll quickly pass the microphone over to my colleague, Daniel, so that he can introduce himself as well.
Yeah, thank you, Zach. And hello, everyone. My name is Daniel Gaeta, and I'm a Senior Solutions Architect at Dragos out of Colorado Springs. Background-wise, I'm a recovering mechanical engineer, so I took the OT path to ICS Cybersecurity and have been specializing in the space for over a decade now. I've worked with Northrop Grumman at the Missile Defense Agency in various roles and with Jacobs Engineering designing cybersecurity solutions for military installations across the globe. And in addition to that, I'm an International Facilities Management Association facility management professional. So looking forward to today's webinar. Thank you, Zach.
Great. Thanks, Daniel. Appreciate the introduction. I'll touch on the agenda briefly just before we dive into the meat of today's conversation. I want to touch briefly on industry terminology and the business impacts of cyber threats in building automation systems. Then Daniel will touch on some of the threat scenarios and scenario demos of those threats in building automation systems, and some highlights from case studies with customers of Dragos. Lastly, we'll touch on some Dragos-specific BAS resources and solutions. And so let's dive right in. So I've tried my best to avoid acronyms so far, but the building automation space, as seems to be the trend with most spaces, has garnered a number of different acronyms and descriptors. At their most basic level, though, these systems and others not listed all refer to the same control systems. FRCS, for example, is typically seen in federal government documentation within the United States. The industry has gravitated towards building automation systems, or BAS as the defining name since I've been in the industry, and I'll use it from here on out to refer to them. So what do we mean when we say building automation systems? At their most basic level, building automation systems are HVAC control systems, and they have evolved from there to where they are today. It's a collection of field devices, supervisory controllers, and a number of servers and clients to control any number of building systems that you see here on screen. You can run the gamut from fire and life safety to physical security. Think access control, card readers, CCTV camera monitoring, or energy and power management or elevator controls. As you can probably imagine, compromise to any of these systems or multiple can have great business impact on organizations that rely on these systems to operate every single day. First and foremost, the greatest potential impacts can be to the physical safety of building occupants, employees, customers, patients, whether through physical access to restricted spaces, outside surveillance through security systems, manipulation of fire and life safety equipment, or dangerous mechanical failures induced accidentally or intentionally to those systems. Second, we're thinking directly about operational impact to these managed facilities. Loss of use is one of the more common results of compromises like this, and losing the ability to control your HVAC system or use it at all will often have a direct impact on the usability of these spaces. Loss of cooling to a data center, for example, renders it completely unable to run the servers in the racks. Loss of cooling to a healthcare facility can prevent patients from residing in entire towers or prevent surgeries from being carried out in their operating rooms. Next, we're thinking about further impacts of a compromise spreading to other parts of a building automation system operator's network. There is potential for a threat actor to utilize the BAS or OT network as a pivot point into the enterprise IT network, or vice versa. That actor then might be able to gain access to protected internal intellectual property or customer data. This can lead to legal and compliance impacts as well, including maybe reporting that compromise to required regulatory agencies or further reports in the media, damaging brand reputation and further consequences farther down the line. So as you can probably tell, losing one system can carry a cascading effect to others that share a network, even if they're managed by different teams or different servers. And you can effectively bring down an entire facility until remediation can take place, which can take exponentially longer given more spread out impacts. Crown jewel analysis is one tool in your belt that can help building automation system operators understand exactly what needs to be protected and where it resides in your environment. It's a top-down process meant to identify explicitly what assets really are the most critical. One analogy I like to use for crown jewel analysis is to liken it to the development of a treasure map, where you're the one burying your own treasure to protect it. If you don't yet know what you need to be protecting and where it resides, whether that's physically in the environment, in the chiller plant, for example, or virtually on your building automation servers or your operational technology network, you won't be able to adequately protect it from those who would like to take your treasure from you. It's an important first step that allows for effective OT cybersecurity practices to be built on top of that. Think vulnerability management, incident response, mitigation, and recovery. In addition, it will expose for the owners of that system where the gaps in your defenses really are, such that proper investments can be made to shore up weak points as soon as possible in a way that makes the most sense for the organization. Now I'd like to pass the microphone over to Daniel to discuss some of the most common threat scenarios specific to building automation systems.
There are 3 building automation system threat scenarios that we'll be exploring further today. In this first scenario, a BACnet detection was triggered, and BACnet is a common building automation systems communications protocol. We'll be going through the 5 W's of this scenario in the upcoming demonstration. Now we're to the interesting stuff. The environment we're using to demonstrate scenarios is modeled and simulated from real-world building automation systems. It includes 2 data centers, one west and one east, and their associated facility-related control systems. Each data center is broken up into multiple segments or zones, like the fire and life safety systems, electrical and power monitoring systems, electronic security systems, HVAC or HVAC systems, vendor and remote access, enterprise, internet, and industrial DMZ zones. The way that we're able to visualize this environment is by using an ICS-OT cybersecurity tool with asset inventory and management capability. So now I'm able to see exactly which assets are in which zone and which are communicating to others. In fact, as I navigate here, I can start to see, let me click on this first data center, the West data center, and it looks like there's traffic originating from the internet that's circumventing the industrial DMZ. So one of the important and valuable lessons from monitoring your ICS-OT network traffic and visualizing it is for this specific use case. But enough about the environment. Let's take a little bit of a look at the first scenario. So the first scenario that we'll be taking at is BACnet related. And so here within the configuration detections of this tool, you can see that there's BACnet firmware, revisions detected, BACnet confirmed private transfer length detections. Let's take a look at one of those. So as we take a look at one of these detections, we start to unfold the who, the what, the when, the where, the why, and the how. So what really happened? Well, in this case, there was a BACnet anomaly or error detected from one host to another, and this could be a technique for causing impact via loss of control to that control system. So we see that it's this remote module and controller 9, where it's within the East 1 HVAC zone, so the East data center, and that HVAC vendor's zone. So the HVAC vendor is communicating with the HVAC system, and there's some sort of BACnet traffic that's occurring that likely warrants further investigation. So why is this important? Well, number one, getting detections like this in the environment and monitoring on a regular basis is critical. In fact, the third critical control from the SANS ICS 5 critical controls white paper is network monitoring and visibility into your space. So we'll pause here as this is the first scenario. Let's move on to the second scenario. The second threat scenario includes a potential brute force attack, which is when multiple logon attempts are made for the same user with different passwords in an attempt to really discover the password for systems that are critical to ICS-OT operations. We'll be exploring this scenario further in the second demonstration. Okay, here we've landed on the threat detections pane of our ICS-OT cybersecurity tool. We'll be looking for authentication brute force related detections. Here in the top right quadrant are threat behaviors, and here we see authentication brute force success and authentication brute force attempts. Let's take a closer look at that authentication brute force success detection. All right, well, here are the notifications that meet that criteria. We can see that they're high severity from a severity 0 through 5 threat detection scale. And we start to better understand from this view exactly what took place. So what happened? Well, there was a successful brute force logon detected from one host to another after 10 prior failed logins. And so it was from an enterprise workstation, that's the source, to the jump host, which is the destination. The NTLM protocol was used, and where includes the zones, which are the enterprise network and the industrial DMZ. But why is this relevant? Well, now that we know that this type of activity occurred, we can likely start an incident response case. So we have several cases to choose from, but we want to look at the authentication brute force case. So back here on the left-hand side of our tool, again, we're now going to go to cases, and we're going to open up that authentication brute force case. The hypothesis is that there was a potential compromised workstation that was producing unusual logon activities, and they were targeting the industrial DMZ, and this was malicious. Well, now I can journal about this case, and I'm going to go ahead and collect all those notifications from that right-hand side that are associated with this case because I'm building evidence. Any PCAPs or Suricata files can also be attached to this case for easy reference. But more importantly, as I think about the incident response plan, having a solid incident response plan also ties back to the SANS 5 critical controls. In fact, it's the first critical control. So having a tool with pre-authored playbooks or incident response checklists is really a game changer when you're considering ICS-OT operations. Let's move on to threat scenario 3. The third threat scenario we'll be exploring today includes a ransomware indicator of compromise detection. Let's take a closer look at ransomware activity and what to do about it. All right, back here to our demonstration environment, I'm going to draw your attention to the bottom right-hand side. So here are the notifications related to that indicator of compromise associated with ransomware. I'm going to bring one up. Okay, so I can immediately see just on the right-hand side that the HTTP protocol was used, and that here I've got a Data Center East video management system workstation directly communicating with an unknown external IP or asset. So quite alarming at first glance because, one, it's not going through the industrial DMZ, it's directly to this internet-facing asset. But also, this indicator of compromise was specifically associated with ransomware when I more closely reviewed this notification. But as we're limited on time, let's jump over to the actual case that would be started if I had observed this activity in my building automation systems. So here's that ransomware case. And before, we had a journal. We collected the notifications for this case, just like we've been journaling, wearing our incident response hat. And we've collected any evidence for this case. But also, it's important to not only be prepared for a ransomware event in your ICS OT space, in your building automation systems, but to be monitoring so that you can detect those types of activities. And then the last step is responding. And so here's a playbook in this ICS OT cybersecurity tool. You have a ransomware playbook that really gives you the steps to further investigate and understand if this activity warrants true escalation and full incident response measures. All right, on to building automation system case studies next. All right, I'll be walking you through 3 case studies where Dragos has had an opportunity to work with building automation system companies and what was discovered. In this first study, we worked with a federal agency that owns and operates a large, complex facility and is starting down their ICS cybersecurity journey. And really, for many clients, that's a 1 to 2 year process. It's certainly a practice at a minimum. Although there were IT cybersecurity protections in place, there was little to no cybersecurity built into the ICS OT building automation systems. And so gaps and risks in using IT tools within the ICS environment also surfaced. And this is just really an example that even large, complex facility owners and operators have these gaps that can certainly be tightened up from a cybersecurity perspective. And so, well, what's the whole point of engaging with this client? Well, one, our technology ended up getting implemented in the space, which allowed continuous monitoring of threats, vulnerabilities, and identification of assets. And so ultimately, by implementing an ICS OT cybersecurity tool for monitoring those assets, they now have a second tool here in their belt to protect their systems. On to the next slide and second case study. In the second case study here, we worked with also a tier 1 tech company to assess critical sites and perform a penetration test. And interestingly, the findings of the assessment highlighted several risks and opportunities for improvement. Some of these ICS OT systems that you see in the middle here are likely well known between Schneider and Eaton sensors and controllers, along with HVAC and mechanical systems. But in the end, what resulted and what was found was that there were dual home servers, network segmentation challenges, publicly exposed building automation systems, and even potential signs of manipulation of BACnet and Modbus protocols. And so certainly noteworthy that plenty of room to continue to improve protections within this space. Let's take a look at the third and final case study. In the final case study, we worked with a tier 1 data center infrastructure provider with over 1 gigawatt of build capacity. A proof of concept was performed at a key site within building automation systems there, and several cybersecurity opportunities for improvement were noted. And a few of those were listed here, and they really align with some of the last areas where we're finding commonalities or patterns. And these are unfortunately just vulnerabilities within the space. And so the question will be, as building owners and operators, what can really be done to protect these building automation systems if we know that they're vulnerable. So coming up next, we'll be talking about what you can do to secure your building automation systems as efficiently as possible. One of my favorite publicly available resources was authored by the SANS organization late last year, and it was co-authored by our Dragos CEO, Robert Lee, and SANS Tim Conway, but it just so happens that Rob Lee is also an instructor and author for the SANS organization who pioneered some of the curriculum there. But the effort of this document that's linked here was to distill the vast array of ICS OT cybersecurity frameworks out there between IEC 62443, NIST cybersecurity framework, and RMF, to CIS and other types of standards, from this extremely large, complex, kind of opaque world, so to speak, into 5 simple critical controls to build a world-class ICS OT cybersecurity program. And so to really focus in on what would bring you the most value to protect a building that you own or operate today, the first question that I ask aligns with this first critical control, which is, if something were to happen tomorrow, do you have an incident response plan prepared? And so do you have that ICS OT incident response plan documented along with the 3 to 5 scenarios that you're likely to encounter, which could be ransomware, so that you're unable to utilize your building automation system, critical systems like chillers or boilers for that matter, maybe a malicious insider or other types of cybersecurity threats within the space. And so that's the first critical control. The second has to do with building a defensible architecture. And the reality is that many building automation systems don't have a very defensible architecture today. And so by referring to this about 20-page white paper, there's a few pages dedicated to each of these critical controls, and I certainly recommend checking them all out. The third has to do with selecting an ICS OT monitoring tool for monitoring your space for threats. It's not about just getting, say, an annual blood test at the doctor's office. It's more about continuously monitoring your network traffic in that space and looking for vulnerabilities or detections that need further scrutiny for potential incident response. The fourth critical control pertains to securing remote access, knowing when your OEMs or vendors are accessing their systems remotely, and exactly how that's done in a secure way will certainly bring the organization value up front. And lastly, are you remediating or mitigating vulnerabilities, or really even implementing a vulnerability management program as efficiently as possible? And that's where the fifth critical control comes into play. And that really targets assets around the building automation system environments, ingress and egress points, which are most likely to be compromised from a threat actor. And so by securing or mitigating vulnerabilities with those assets first, you would be making the fastest or the greatest advancements in your ICS OT cybersecurity program. Back over to you, Zach.
Great. Thanks a lot, Daniel. To cap off our discussion here today, I'd like to take another moment to show you how Dragos approaches building automation cybersecurity with our customers. Dragos provides value in what I consider to be 3 separate pillars. First of which is our threat intelligence team. These folks are the best in the business in open internet threat research, malware reverse engineering, ingestion of new public vulnerabilities, physical OT device penetration testing, and so much more. They then gather all of that research and knowledge together and disseminate it to our customers in easily digestible formats through our worldview reports. The second of those pillars is our global services team. These are our security professionals that have years of experience in both the security space and oftentimes as operators of OT systems in environments that our customers come from. They have an intimate understanding of how these environments operate and almost more importantly, the inherent constraints that OT system owners operate underneath. They can conduct a wide range of one-time or ongoing services engagements for our customers, including architecture reviews and crown jewel analysis, as we mentioned prior, to threat hunting, penetration testing, and incident response retainers for our customers. And last but not least of the 3 pillars is our Dragos platform. This is our hardware and software technology solution that allows for utilization of our vast threat intelligence knowledge, codified within it, and utilization of that at machine speed. It's utilized by our global services team as the primary tool in conducting their services engagements with our customers, and can also be operated fully independently by security professionals within our customer organizations. It enables asset identification, passive continuous network monitoring, and vulnerability management for OT devices within your building automation systems network, and so much more. And with that, I just want to thank you all for spending this time with us, and we can move on to any questions that we've had from the audience. Okay, so what is some low-hanging fruit to help begin securing building automation systems quickly? I would say that first and foremost is sort of, as I mentioned earlier, when we were talking about crown jewel analysis, is knowledge is power in a lot of aspects in terms of beginning your the journey in securing your building automation system. So understanding what you have in your facility is most important, whether you do it manually and kind of discover what assets you have in your environment, or do it automated through something like the Dragos platform. And then when you sort of do a thought exercise around how you would respond in case of an incident. So Daniel mentioned incident response planning is sort of a key aspect of doing that. But oftentimes one of the biggest keys to getting a building automation system back up and running in case of an incident is making sure that you've been performing continuous backups over the last months and years that you can restore should you end up in a place where your building automation system needs to be isolated and rebuilt. Having a backup that you can refer back to and restore will make that go so much faster and so much more painless, especially if it's been done continuously and those backups have been being stored in offsite locations that will prevent it from being compromised alongside the system when it's compromised as well. Here's another question. Who should be responsible for cybersecurity of a building automation system? Whether it's the contractor, engineer, the owner. I would say that in my experience, it's the building automation system owner that takes responsibility for the security of that system on their site. Typically, it's not the building automation system contractor. However, the vendor of those building automation systems carry a ton of responsibility in the development of the hardware and software for those systems, kind of, like I said, as they're developed, and then as vulnerabilities are found either by their team or by external security researchers, those teams will make software revisions and updates to those devices as those are found. But it is truly the responsibility of the owner to make sure that, again, these incident response plans and backups are being completed. Things like that are very crucial. And again, it should be taken on by responsibility of the building automation system owners in most cases.
Yeah, I'm seeing a question here. How would I design cybersecurity into my building? And certainly a great question there, because there's so many standards out there. And so on the architecture and engineering side, I'd say really the time is yesterday to start thinking about cybersecurity in your building automation systems. And that applies to not just the preliminary architecture and design of your building from a specifications perspective, but even if you're an owner or an operator, we could start yesterday thinking about how to start incorporating cybersecurity throughout your building systems. And one resource I'd like to share with the community is Unified Facilities Criteria 4-10-6, which is cybersecurity of facility-related control systems. And that gets into a tremendous amount of detail, depending on if you're looking at energy management and control systems, or power management systems, or cranes, or any type of industrial system. That documentation goes over all of the design considerations and the specifications that need to be developed by a number of standards organizations here within the US. So definitely would recommend checking out that resource, but would also reinforce that when considering cybersecurity, absolutely those architects and engineers, the sooner that a specification that can align with even those 5 critical controls, the sooner that can be done, the better, in my experience. Also, seeing another question here, how has policy changed in the building automation system space? And I'd say that we really haven't seen a tremendous amount of building automation system specific policy recently. However, we've seen an update to NIST 800-53 Rev 5 was recently released, but that's a bit more generic. In general, I'd say that it's policy that's going to have the biggest impact in the long run on how these systems are protected in the future, and whether or not if a building owner, if there's a cybersecurity incident and critical information is shared over, say, a building system, who would be responsible? And that's not really clearly understood today. I will share that Dr. Lucia Niemeyer is pioneering efforts into space to create some form of a cybersecurity building ranking system, relatively similar to kind of like LEED in the environmental space, for example. And that could be something that gains traction in the future. But I absolutely expect policy to mature in this space. And because there's not as much policy and procedures and cybersecurity standards regarding building automation systems, I think that ultimately is one of the key reasons why there are so many vulnerabilities in the space. So hopefully that improves over time. Thank you.
All right. Well, thanks so much for that informative presentation, Dan and Zach. In a moment, we'll continue our Q&A portion of the presentation. So if you do have a question you'd like to pose, please do that now. You can just drop that question in the chat window there. But before we get to more questions, just a quick reminder, we don't want you to miss the event resources section. If you haven't done it already, you can view or download these valuable resources that include a PDF of today's presentation slides, an infographic on identity and protect the crown jewels of building automation systems, as well as a white paper on cybersecurity risks of leased data centers, a solution brief on cybersecurity for building automation systems, a case study on the critical environment that runs data centers, as well as Dragos, their request demo link, if you'd like to learn more and see a demo. So with that, we'll continue our Q&A. Daniel, it looks like we have a few more questions from the audience here. And the first one is BAS the same as building management systems or BMS?
Yeah, great question. And the entire space is really an alphabet soup, so to speak, of acronyms. Building automation systems, that acronym, building management systems, they essentially refer to the same thing. You could say that there are nuances in ultimately what those systems refer to, but in general, from a practical, pragmatic perspective, building automation system, building management system, same thing. Facility-related control system, utility monitoring and control system, they are all similar and related.
Great, okay. Next question here in queue. What is the most important physical security aspect in securing your assets?
Yes, interesting. Well, physical security is an important part of any facility and infrastructure design. And that's really, I'd say, where the security starts, in that all of your critical industrial control system controllers typically reside in mechanical rooms or electrical rooms. Well, those all need to be physically secured. Any thermostat with any type of connectivity or peripherals or human machine interfaces or devices that ultimately control the facility need to be protected behind a locked door, and there needs to be monitoring of who's accessing those spaces and when. So physical security is a huge aspect of facility design, and it's always a challenge to ensure that those facility occupants and those utilizing the space are doing so in a safe way, where they're also not getting access to those critical control systems and controllers, because more often than not, sometimes those systems can't and aren't protected.
Yeah, absolutely. That's great. Keep those questions coming to our audience if you have more. The next one we have for you, Dan, is how to handle the security of CCTV cameras. Commonly, they're connected in some sort to the manufacturer's servers, especially those that came with a free app for easy access. So how do you handle those?
Yeah, great question. And that really kind of delves into how more and more smart facilities are getting connected, but in ways that weren't connected before. And CCTV or systems are a part of a larger video management system, which is a facility subsystem. That video management system is part of the electronic security systems, I should say. And all of those systems could potentially be linked back to vendors or third-party contractors that are monitoring your electronic security systems. And those are potentially huge avenues of risk. The question is, are your security vendors accessing systems during approved times? Are they remotely accessing those security feeds during approved times? Is there secure remote access in place? The same goes for remote monitoring of your HVAC systems equally in terms of just, yes, the CCTV systems could be avenues of kind of malicious risk, so to speak. But ultimately, I'd say to be very careful about any devices that you choose to enable external connectivity with, and to ultimately focus on building a defensible, segmented architecture. Because when we look at the exploits that have taken advantage of building automation systems historically, the vast majority of them have used, say, an HVAC contractor's access to the network for the purposes of then pivoting into the financial systems and then compromising the systems in further ways. So,
for sure, yeah. And and speaking of breaches, have there been any real building automation cybersecurity attacks recently?
Absolutely. Ultimately, just not too long ago, back in 2021, a German facility operator ultimately reported that they had a compromise of some of their KNX devices, in which all of the building automation systems that they would typically have access to, they were essentially locked out of in an effort to ultimately gain some sort of a ransomware collection. But that's an example of more of a direct exploit of a building automation system. And as we look throughout time, I mean, there was a U.S. casino was breached where an aquarium thermometer was used to exfiltrate data from the network. That's another example of a use case that we're looking at, which is compromising these building automation systems to, number one, keep folks from being able to occupy the building because it's too cold or too hot or whatever operation that's going on within that building itself. Two, I'd say the other huge risk is the exfiltration of sensitive data, whether or not it's financial systems or otherwise. Any sensitive data that's stored within a facility, and we look at all of these endpoints that lots of folks don't necessarily secure, like thermostats. Well, data flows over a wire there just as freely as it does any other wire. And so the question is the data within these facilities secure when there's these outlets that are opening up so frequently to externally internet-connected locations? And so security has not been a thought in the initial design of these systems, and it's going to start becoming more and more of a discussion point, in my opinion.
Yeah, definitely. All right, thanks. Another question for you here, Dan. What approach should contractors take when upgrading existing buildings without previous IoT's infrastructure?
Without previous infrastructure, say, experience in upgrading those facilities, or is the question that there's contractors entering the environment, they're looking to assess, say, the security posture of a facility? I think that's perhaps the direction of that question. Well, to answer that, I'd say if I were a contractor entering a space, the question is, like any facility I walk into, you got your as-built and your as-designed. And most facilities don't stay as-designed very long. And there's red lines left and right. Facility systems are changing here and there. And there's all this risk for devices to be added. So the first question is, you need to establish a baseline. And so what do you have within that facility ultimately? And so can you start then to use an ICS OT tool to monitor the devices within your building automation systems that are communicating on the network? And once you're able to understand the devices that are communicating within that facility, you can then form a reasonable baseline understanding of all of those facility systems that are operating there, the fire and life safety systems, the electronic security systems, including the CCTV systems, all those energy management systems, if the facility is operating and HVAC's working as designed, all of those will be sending communications to all the various controllers. And so when you understand those systems and assets that are in place, you can then understand what vulnerabilities exist with all of those assets first and foremost, and then understand, are there any threats that are currently visible, because are there concerning communications associated with threat behaviors occurring on the network. But just by getting visibility into the system, I'd say would be the first step. And from there, deciding what key changes can be made. In fact, I go back to that 5 critical controls reference. What key changes can be made to make to get the biggest bang for my buck, so to speak, when it comes to implementing cybersecurity in that facility. And I'd say, back to the 5 critical controls, do you have a defensible segmented architecture, or is it flat, like we find in many cases where you don't have a specific VLAN allocated for, say, the EMCS or other types of systems? And so in my experience, kind of like building back to the physical security point, why lock your door at home? Well, just like in this example here, why implement a defensible segmented architecture? Well, it's not going to be a matter of if an event is going to occur. It's a matter of when. But by making it as difficult for that passerby or that malicious outsider to potentially remotely access your systems, you're going to create then a tool belt, so to speak, that's going to empower you to be as effective as possible in your defenses against any type of really future threat that would apply to your buildings that you own and operate.
Yeah, definitely. Okay, great. I think we have time for a couple more questions. Next question is the threat landscape for building automation systems changing? If so, in what ways?
Absolutely, absolutely. And for years now, we've been seeing more and more devices produced with connectivity to the internet, smart buildings, Industry 4.0, IIoT, IoT, I mean, a whole bunch of acronyms, right? But the reality is that we're seeing with these smart facilities a transition from an environment that historically, before we had all these connected devices, was much more heterogeneous or unique, in that a facility system designed for one facility was unique to that facility, and it would be very hard to, say, create a cybersecurity exploit that would apply to many facilities beyond just that one. But now, so many more smart building types of devices and systems are being integrated and connected to the network that we're seeing much more heterogeneous systems and standard protocols in use. And what this is doing is it's really opening up the landscape. This digital transformation, it has kind of 2 sides to it. One, it makes it much easier to automate systems, to remotely monitor them, to do our daily kind of O&M for facilities. But 2, it also creates a potential risk surface or route, an avenue for threat actors to remotely access these systems. And so really the transition has been from a heterogeneous type of state before into a more homogeneous state today, where the real risk is skyrocketing, in that as these building automation systems have known vulnerabilities, the main protocols we see in this space have known vulnerabilities. And so as kind of the exploits mature in this space, and because the space is more homogeneous, I absolutely anticipate there to be a rise in the ransomware that's directly targeting building automation systems for the purposes of making a profit. And although that's unfortunate, what we can do, though, is be as proactive as possible, build that defense in depth, take a look at those 5 critical controls if time permits, because those will give you the biggest strides forward in designing an ICS OT cybersecurity system for your facilities, which I'll be the first to say isn't easy. It can take clients 1 to 2 years to build a program, but you have to start somewhere, and building that defense in depth is really going to help you in the long run.
Sure. Yeah, definitely. Okay. We've got one more question here. Could you expand on the potential impacts from a BAS cyber incident?
Yeah, absolutely. The costs associated with a building automation system successful cyber incident are tremendous. And if we look back at kind of just a recent example, certainly won't call out the company, but it wasn't a cybersecurity incident. But if we just look at, say, a human operator error induced outage at, say, like a data center where cooling was lost in this recent news article, there was millions of dollars of revenue lost. And so in that type of example, if we look at any other data center operator or facility operator that's hosting a really costly event, and someone were to target these systems, there would be a huge financial potential impact to the bottom line. And that can be experienced in many ways. But also that can tarnish the reputation of the facility owners and operators if there's a cybersecurity incident, and that could indicate that if I'm a business kind of owner or an operator, maybe I don't want to do business in certain types of facilities, for example. So there's oftentimes many effects of a successful cybersecurity incident in the building automation space. I've already mentioned the potential risk of exfiltrating sensitive data from within the city as well. And I absolutely anticipate that being one of the primary continued objectives of building automation system exploits, which is utilizing those building automation systems to further exfiltrate data, say, from critical financial systems, from point of sale systems, anywhere they can make the most amount of money for the least amount of effort.
Well, I think that's it for our time today. So on behalf of EBM's Building Group, we'd like to say thank you to our sponsor, Dragos, and Dan and Zach for presenting for us today. And thank you to our audience members for joining us. We hope you enjoyed today's presentation, and we'd like to ask you to take our exit survey that you'll see at the conclusion of this session. It helps us to better craft future webinars and content for you. Thanks again for attending, and have a great day.